Hi, and welcome to 2.1 Properties of Radical Functions. As you may remember, a radical is the square root and other types of roots. For the get started, what are the domain and range of each function? The domain, if you recall, is all the different possible x values that you might get, and the range are all the possible y values in that function. There's no restrictions here. These arrows are going to go off forever, and x is all real numbers and y is all real numbers. Pardon me. And now in the second one, x can be anything. X is going to continue to go off forever in positive and negative directions, but you'll see that the y values, the range, is limited to greater than or equal to 1. So if I click on Show Solutions, you can see the way they do their notation. The x is a member of all the set of real numbers, y is a member of the real numbers. Here the function's quadratic with a minimum of 2.1, so the domain is all real numbers and the range is greater than or equal to 1. Let's go to the bottom. We're going to get ready here to graph y equals x and y is equal to the square root of x. So this is we're going to take a look at what does it look like when you graph a radical, when you graph the simplest type of radical, y is equal to x. So if we fill in this chart, first of all, if y is equal to x, then basically we're just going to be copying these numbers all out. So these numbers are all completely the same. But now what happens when we do the square root of the value? So here y is equal to the square root of x when x is equal to -4. Now here we're breaking one of the rules of math, aren't we? We can't find the square root of a -4. If you type in -4 in your calculator and you hit the square root button, it says error. So undefined, I guess, is the one way to write it. So this is going to be undefined, 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 undefined. How about the square root of 0? The square root of 0 is 0. Okay, so you'll notice that this is 0 as well because we just recopy these numbers. This is an interesting point. So wherever in this function, wherever y is equal to 0, this function is, we also get a 0. So that we're going to notice this a little bit later on. The other place that takes place is 1, because the square root of 1 is also equal to 1. I'll leave this for a moment. Here this is 2 and 3 and 4. The square root of 2, root 2, is, if I round it to the nearest tenth, is 1.4. The square root of 3 to the nearest tenth is 1.7. The square root of 4 is 2. Now here's an interesting one. So here we get 0.25. The square root of a quarter, this is 0.25, is the same thing as a quarter. So if I have a quarter, it's the same thing as 0.25. Now the square root of a quarter, it's the same thing as the square root of 1 and the square root of 4. So it's the same as thinking like this. Okay, now that is equal to 1 over 2, which is 0.5. So you'll notice most of the time these square roots, they're smaller, right? Square root of 2 is 1.4, square root of 3 is 1.7. Here's an exception. Between 0 and 1, the square root actually makes the number larger. I'll click on, pardon me again, I'll click on Show Solutions. Here you go, your answers. We just have a dash for undefined because we can't do the square root of a negative number. And then this equals with the dot means that it's around approximately 1.4, approximately 1.7. So now on the next page, we're going to graph that. I'm going to go over to the desmos.com and graph that. And so I've got these two. Make things a little bit neater. Here's my... how can I make things disappear? Okay, so here's my y is equal to x, and now my y equals the square root of x looks like this. So you'll notice that we don't have any x values in the negative side because those were undefined. We can't do the square root of a negative value. And again, the important part is that between at 0, 0 is a common point, and this point here is 1, 1. Right, so this point and this point, both graphs are going to be touching it. You'll notice on the square root, the y is equal to the square root of x. It goes above the line, it goes above y equals x first, and then goes under the line. We're going to see that pattern happen over and over again. And these lines, of course, go off all forever. A couple other places here, if you take a look at where on y equals x, where y is equal to 4, on the square root sign, it kind of makes sense. The square root of 4 is 2. If we look for another common one, way up over here, here's 9. So in the square root one, and the y is equal to the square root of x function, here it's 3. So a pattern is the 0, 0 is the same. Wherever y is 0 in the original function, in the square root, it's still 0. Wherever y is equal to 1 In the original function, the square root 1 is equal to 1. We've got this over and then under pattern, and then wherever we see, we know our squares. 4, square root of 4 is 2, and so on. So let's take a look back here at our next page. They're mentioning the same thing. I think our graph looked a little bit nicer. Taking a look at the bottom of this page here, there's a couple important things. They're defining now a radical function, not just for y is equal to x and y is equal to the square root of x, but anytime you can do y is equal to the square root, y is equal to the square root of any kind of a function, where f of x is a function. So if you have, here's the original function, y is equal to x plus 4, here is the radical version of that. It's y is equal to the square root of x plus 4. Let's just analyze that one just for a second. So if I was to make a chart here, I'll say, okay, here are all my possible x values, and then I could graph my x plus 4, right? So this is like saying, here's my x and here's my y. So same thing as before, I could start with like -2, -1, 0, and so on, and that would produce this graph for me, right? And then if I made another chart here, and if I said, oh, what about then the square root of x plus 4? When am I going to get a value here that is undefined? This one will be undefined when this value is negative, right? So in this case, say if I put in a -5 here, this value would be -1, and then this one would be undefined, right? There'd be no answer there at all. I'd have to just leave it blank. So looking at my graph, this line here is my y is equal to x plus 4. Right? This is my square root of x plus 4. And you'll notice if I go to -5, sure, I get a point here, but there's the y is equal to the square root of x plus 4 only starts at -4. So -4 gives me a 0 here, and this gives me a 0. Okay? Now here's the same pattern we saw before. It just got shifted over, didn't it? So when in my original function, y is equal to 0, the square root version, the radical version, it's at the same point. It meets at two places, always where y is equal to 0 and where y is equal to 1. And we get that same pattern of it going over the line and then under the line. Okay? And remember the other pattern we're looking at 4. When the original function had a y value of 4, now my square root sign has a y value of 2 because 2 is the square root of 4. Here's another example of -x plus 2. Things have changed a little bit. It's pointing over to the left. Not a bad idea to think about this mathematically, where we have to make sure that what's underneath the square root sign has to be greater than or equal to 0. So this is where we're figuring out our domain. What are all the possible x values? And you say, okay, what's underneath the square root sign, -x plus 2, has to be greater than or equal to 0. And see, they do two operations here. They're subtracting 2 from both sides, and then they're multiplying each side by -2. So this, here, I'll show you the steps. Your next step would be -x is greater than equal to -2, and then multiply both sides by -1, so you get positive x, and this is where you switch that sign, is less than or equal to 2. So that's where this comes from. So the domain here would be x is less than or equal to 2. The original function, -x plus 2, is this line here, and you see the square root sign now. X has to be less than or equal to 2, so that's where this line starts and goes this way. Okay. Again, we have the two invariants, where in our original function, y is equal to 0, here's this one, and in the original function where y is equal to 1, like that one, and then we go over the line and then under the line like that. I did it a little bit messy. Looking at the next page. Trying to look at the next page. Here we go. This is what I mentioned. If 0 and 1 are in the range of y is equal to f of x, so in other words, if the y if the y value of 0 and the y value of 1, if that exists, then these also exist in the square root, in the radical version of it. So these are invariant points. They're in both of them. And then this here is a little bit wordy, but it's describing that behavior of going above it between 0 and 1 and then below it afterwards. Let's try, here I'll hide the solutions here. Let's take a look at this first example. And it says, for each graph y is equal to f of x below, sketch the graph of this and state the domain and the range. Okay, so I want to draw on this. So here, just interpreting this a little bit, when the y values are negative here, that's the f of x is the y values, I cannot do a square root of it. So the domain, the possible x values here is only the x values of my square root of f of x can only be where that f of x gives me back a positive value. So the domain will be x has to be equal to, from this leftwards, so less than. So x has to be less than or equal to, what would that be, -3. Yeah, -3. So there's my domain. Okay, my two invariant points that I'm going to plot is when on my original function when y is equal to 0 and when y is equal to 1. Okay, and then we do that same pattern of going over the line first and then crossing there and then going under the line. Okay, it's kind of hard to find one of the square root examples. It would be when the y value was 4. So this is 1, 2, 3. It would be up here 4. So that would be hit about here. If we extended that line, it would be the same as 2. So that we should probably hit the 2 right about there. Okay, so that's what our arrow would look like. The other question is the range. So the range would start at 0 and go larger. So x has to be greater than or equal to 0. All right, so let's take a look at the solution that they write here. Oh, here's their sketch. F of x is greater than 0 for all values where x is less than or equal to -3. So there's your domain, and so on. And so we've got our sketch. Looking at our second one, let's do a sketch here. We need positive values, so the domain x is going to have to be greater than equal to, what is that, -2. And the range will be values above 0, so the y values have to be greater than 0. And now when I'm drawing this, here's my first invariant where on my original function the y value is 0, and on the original function where the y value is 1, it's right here. Oh, trying to draw it. Sorry. Right there, and now so I go over it first and then I go under it, and I'm going to think ahead and find a few points. So when the y value is 4, the square root of 4 is 2, so I'm going to go through that spot. When the y value is 9, then the square root of 9 is 3, so I'll hit that spot. So then I have to kind of follow this pattern here. Okay, it's not quite a straight line. The square root symbol, the pattern of it kind of looks like that, sort of like hooks over to the right. So it starts here. So I put a hard circle there to show that it stops there, and it includes the 0 and includes the 1, and then an arrow here because it keeps on going forever. Let's see their solution that they have. Is it on the next page? There, it looks something like that. Okay, I'm going to give you a quick minute here. I'm going to pause it, and I would like you to try the check your understanding 1A, and then I will be back. Thank you.